All right. So we are joined now by Alan Early. Alan, why don't you introduce yourself for the guests?
Hey Nathan, thanks for having me on. My name's Alan Erdley. I'm a senior edge go-to-market specialist, specializing in CloudFront and a couple other of our edge products.
Awesome. So Amazon CloudFront, it's a service that I've used over the years. I've come to think of it as sort of a foundational service for anything that is internet facing. But why don't you explain it in your own words? What Amazon CloudFront is for any guests who arriving. Maybe they've heard of CloudFront but haven't used it, or maybe they've never actually heard of Amazon CloudFront.
Yeah, sure. So CloudFront's all about optimizing performance for those web-facing applications. So CloudFront does a great job of accelerating content delivery for both static and dynamic assets. And there's a couple ways that it does that, but one of the core ways is that by having a network of edge locations that's all around the world that brings content closer to your users. But it also really leverages the AWS private backbone as well to accelerate traffic between AWS edge locations and AWS regions where applications are hosted.
Awesome. So
Yeah.
so I'm starting to understand, what it is. What is the new announcement that we're going to talk about and focus on today with Amazon CloudFront?
Yeah, so we're here to talk about the expansion of the free tier, which is, as you know, there's many AWS products that have a free tier, and CloudFront's no exception. And it was expanded back in December, and that's something we're really excited about. And this is a really meaningful kind of expansion for CloudFront. Every AWS customer can now get a terabyte of data transfer out of CloudFront for free, 10 million HTTPS requests, 2 million CloudFront functions invocations. So this is a really meaningful kind of way that we're hoping that customers take advantage of this to leverage CloudFront for their workloads.
Nice. That sounds like a lot of data. I've run a few websites, like small websites, like personal blogs and stuff like that, and I don't think I've ever hit a terabyte of data transfer for, a small website, or even some small startups that I've worked at. They have trouble hitting 1 terabyte, especially if they're using compression and stuff like that. So sounds like this is pretty extensive. Sounds like it's gonna be pretty useful. Um,
Totally, yeah. A lot of our customers are going to get CloudFront for free completely now, which is really cool.
yeah.
Awesome.
That is pretty cool. Um, so thinking about CloudFront, uh, I'm used to using CloudFront with static content for sure. Anytime I have an S3 bucket, I have some images in there, maybe some video files, something I want to serve down to people. Is that all that I use CloudFront for? What other capabilities does CloudFront have that I should keep in mind?
Yeah, so CloudFront's great at serving those static assets, right? That's kind of like core CDN functionality, and CloudFront does a phenomenal job at it. But CloudFront's also really uniquely positioned, I believe, because it leverages the AWS network to have these private links back to AWS regions. So that means that it does a really good job of accelerating dynamic workloads as well. So on the Edge team, we always kind of say that we believe that every byte of HTTP or HTTPS traffic that leaves AWS should be going through CloudFront. And that's static content like images, videos, some HTML that's delivered to multiple users, and dynamic content that might be loaded off of EC2 instances or ELBs or things like that, where every request is as unique as the person that's requesting it. And so we believe that CloudFront can do a really good job of accelerating that dynamic content. There's a lot of reasons that CloudFront does a good job of it, but AWS's backbone network is one of them. DLS termination at the edge is another really big one.
Have you guys seen any improvements for your customers in terms of the dynamic workloads? Can you tell us a little bit about that?
Yeah, absolutely. So there's been a ton of performance improvements for a lot of our customers. And it's one of these mileage may vary sort of situations, but it's almost every customer that uses dynamic content acceleration through CloudFront will see performance improvements. And that's because we're doing a lot of things to optimize that delivery. One of those things, like I said, TCP and TLS termination out at the edge really makes a huge difference. Persistent connections between the edge and the origin that keeps those TCP connections alive and active so that they're ready to serve content right away. Um, you know, we've seen customers that have had performance improvements well north of 20, 30%. And again, its mileage may
Wow.
vary depending on where you're located in the
Right.
world and where your workload is.
Yeah, I know I've personally seen this in action when I deployed CloudFront in front of an API that was being used. It was a social media app used from all around the world. And we went from some of our applications taking about 5 to like 600 milliseconds to actually initially connect to the API to under 100 milliseconds, just because that TLS handshake is going back and forth much faster to the edge location than all the way to the United States and then all the way back to overseas over a network cable, running through the ocean.
Exactly. It makes a big difference.
So this is really fascinating. I love talking about CloudFront, but what I like even more than that is actually seeing it in action. So my understanding is you
That'd be
have
awesome.
a demo you'd like to show, right?
Yeah, let's take a look at one.
All right, let's bring this up.
All right. So what I wanted to show today was an example of how easy it is to set up CloudFront for both static asset caching and also dynamic content acceleration as well. And so what I set up for us was a quick demo application. This is a super simple application. And it's really a random number generator that generates a number between or from 1 to 6. And we represent that number in both text form, right up here in the title, but we also represent it in graphic form in this picture of a dice, right? So this is, like I said, a super simple application. This is currently running in Sydney, Australia. I'm located in Boulder, Colorado. So about 8,500 miles away from me. So it's a long distance away.
If
And
I
I did
if I
that.
remember correctly, that's probably around like 150 milliseconds of latency at minimum, right?
Yeah, I mean, it takes some time to load, that's for
Yeah,
sure.
you're
So
dealing
it's
with speed of light limitation, going all the way across the ocean.
yeah, I mean, Nathan, you might be able to do the math on the fly. I can't, but it is a long time, right? So that's the moral of the story here. And what I wanted to show here is that we've got a mix of static and dynamic assets on this application. These are basically the assets that are loading for this particular app. This is an HTML file, and that HTML file is really simple. It has reference to an image, reference to a style sheet, and the text that says you rolled a 5. And then we've got a couple static assets that are our CSS file, and then also our image file. All of these things are being loaded off of an EC2 instance that's behind an ELB in Sydney, Australia. So what I wanted to do is take you over to the CloudFront console and set up an actual distribution so that we can improve the performance here. So let's do that. So I'm here in the CloudFront console, and it's really easy to set up this distribution. So what I'm going to do is I'm just going to get a couple things ready over here on my other screen, but I'm going to click Create Distribution. And we're mostly going to go with the default settings for CloudFront today because they're really good. Just out of the box, it's really, really good to go. So the first thing that we're asked to do when we create a distribution is to set our origin environment. So this is, where does the content reside? And so I've got this ELB endpoint that I'm going to just load in here. And I'm just putting in basically a publicly facing URL. So we have a couple other things that we have to configure here. Like I said, I'm going to leave things mostly in their default setting, but because this is a dynamic application where we really don't want to be cached, we need to change the caching policy before we create this origin. And so I'm going to go in here to this into the cache policy area, and oops, sorry about that. I'm going to say caching disabled. So this is going to say to CloudFront, hey, I want you to front this website, but I don't want you to cache anything yet. And there's good reason for that, because we want that random number to generate every single time. And I'm going to leave everything else the same. I'm going to give this a quick demo or a quick name, live demo. There we go. And then I'm going to click Create Distribution. Now, there's a few other things I want to do here before we take a look at this site. And one of those is I don't really want my static assets to be loaded off of that EC2 instance. It's kind of unnecessary load that we can do a better job of loading that information off of S3. So I want to create a second origin and set up a different cache behavior for that origin. So let's go back into this origins area, and we can see that we have our custom origin already created. That's the default one that we created when we created the distribution. And now we're going to create a second origin. So let's go in here, create an origin. And I'm going to enter in the location of an S3 bucket that I've got in my account. We're going to leave most of the settings here as the default, but I do want to set this, use this origin access identity. And I've already got one configured. For simplicity, we're just going to click through this really quickly, but this is super easy to set up. The wizard kind of takes you through the whole process. And that's it. So I'm going to create this origin, and now we've got 2 origins created in CloudFront. There's one last thing that I have to do before we go live with this website, and that's set up a cache behavior. So like I said, we want the index page, the HTML page, to load off of that EC2 instance that's located in Sydney fresh every time, because we want a random number. But we want the other assets of this distribution to be cached. So we want the images to be cached and delivered from the edge locations that are located around the world. So we're going to set up a cache behavior for that origin that we just created from S3. So I'm going to create a behavior here. And then we need to set up a path pattern. So if we looked at the index page, that HTML page, we'd see that all those static assets are located at the following path. So /static/ and then we're going to put star as just the wildcard to reference, everything that exists at that static path. Then I'm going to select the origin here as our S3 bucket that's also located in Sydney. Compress things automatically. I'm just going to leave basically everything else the same. And you'll notice here that in our cache settings, we have caching optimized. This is the recommended setting. It comes out of the box ready to go for you. So you don't need to do anything other than click create behavior. So that's really that's the whole configuration that we wanted to do with CloudFront. So what's happening right now behind the scenes is CloudFront's going out to all 310 plus edge locations that we have around the world, updating the configuration so that those edge locations are ready to accept this traffic. It takes a couple minutes to do that, but we'll see this be ready to go here shortly.
Wow, that's pretty impressive. So it sounds like we have a couple of minutes to work with. In the meantime, I want to ask some questions about what I was seeing there. So I saw you set up 2 origins there, and you set up 2 different behaviors. So let me make sure I understood this correctly. One of them is serving static content. The other is actually serving dynamic content that changes from request to request. And so what'll happen is the static content will be served from a local nearby, CloudFront presence, and then the dynamic content will actually go all the way to that server that you set up in Australia, and the response will come back on every single request. And I can split this out depending on the path, right?
Exactly. Yeah. So we're going to load content off of a local POP to us, a local edge location for that static content, and we're going to see that it's cached. And I'll show you that here in a minute or two.
Wow. So this is really exciting. This makes me want to use CloudFront even more, especially now that there's expanded free tier. But there's some other questions that I have about the dynamic workloads. How does that dynamic workload actually get improved by CloudFront? Because I might be thinking to myself,
Right.
I understand CloudFront is going to bring that content closer to my end customer in Colorado if there's a local CloudFront presence in Colorado. But what's the benefit of using CloudFront for going all the way to Australia and back? Can you explain a little bit more about the rationale behind using CloudFront for the dynamic paths as well?
Absolutely. So when you make a request to any website, you need to establish that connection to the website. And that typically involves, that certainly involves a TCP connection, right? Just standard base level networking connection that needs to be established. Most websites now are also loading via HTTPS, which is TLS. So the establishment of a TCP and TLS session involves multiple round trips before you can even start getting content. So with a ELB, whenever you're connecting to an ELB or an EC2 instance that's directly to the internet, you are going to the location of that ELB or EC2 instance every single time you make a connection. And so when that instance is located in Australia, 8,500 miles away from me or so, whatever it may be, that takes a long time, right? I'm making 4 trips to and from Australia just to start getting content. So that feels a little inefficient to me. So with CloudFront, what you can do is, or what CloudFront does automatically, is move that TCP and TLS termination to the edge. So wherever the POP is that you're connecting to, and that makes a huge difference. So for me, that's typically a Denver POP, 25 miles down the road from me. It's a big difference from the 8,500-mile round trip that I have to make to establish this connection to Australia. So that's one thing. The edge locations, the CloudFront POPs are also keeping connections open to the origin environment. So that means that when you connect to that edge location, that you can immediately start requesting content from the origin server. So from that dynamic server, you're going to be able to start requesting content straight away. And you're not going to have to reestablish that TCP and TLS connection from edge location to origin environment as well. And it all rides over the AWS backbone, which is a huge benefit that you get from using CloudFront. And I should also mention that most of the time when you're deploying either a static or a dynamic workload, it's typically cost neutral for you on your AWS bill.
So Alan, you mentioned, oh, sorry, Nathan, go ahead.
Go ahead, Tasha. Go ahead, Tasha.
I heard edge compute there. Is that a part of the free tier as well?
Yeah, so there are 2 million CloudFront functions invocations included in the expanded free tier for CloudFront. And that's a pretty big deal because that allows you to do a lot of things to, it's sort of like the first line of computing that happens when you enter into the AWS network is that CloudFront functions. CloudFront functions are lightweight JavaScript code that executes in every edge location that we have. So it's a great tool for maybe doing some like header manipulation, setting cookies, things like that. It's a really powerful tool. And it's included in the free tier.
That's awesome. That's fantastic. So next up, what about the security aspect? How is CloudFront helping with the security?
Yeah, so CloudFront does help with security. So there's a lot of really goodness that happens when you deploy a CloudFront distribution with any of your applications in AWS. Number one, every CloudFront distribution includes AWS Shield Standard, the DDoS mitigation service that we offer. And that comes included for free with your CloudFront distribution. So that's protecting against those big volumetric DDoS attacks that can really do a number on a website, take down websites. And so having that layer of protection is a really good thing to start with. It should be mentioned that CloudFront's also specifically designed to handle traffic spikes and large volumes of users. So having Shield Standard and CloudFront is a great way to protect your application from denial of service attacks. There's a lot of other things we could talk about. I mean, we could probably talk for several days about security, but there's really easy integration with AWS WAF bot control, just a bunch of different things that make it easy to improve the security posture of your application.
For sure. And one more surprise question for you that I was thinking about as you were talking about the acceleration for the dynamic content. My understanding is that if I'm talking to an ALB, let's say as in your scenario in Australia,
yep,
my traffic is going to go over the public internet all the way to Australia, and then once it's in Australia, it's going to enter the AWS network, go to that AWS ALB, and then the AWS ALB is going to serve it back from my application running there in Australia. How is that different from CloudFront?
So CloudFront, or every edge location that CloudFront has direct connectivity back to AWS regions. And then of course our regions have connectivity between regions. So that means that instead of riding over the public internet where you might exchange between 3, 4, 20 ISPs, however many are along that path to Australia, you're going to ride over a limited number of ISPs. So you're going to connect, as soon as you connect into that edge location, you're immediately going to be riding on the AWS backbone the rest of the way. And that's a really good thing because it's predictable, it's high quality, it's going to give you the performance that you come to know from AWS.
That is super cool because when I think about building a backbone, it's something that large corporations have to do, and it costs a large amount of money. But here you're able to get on the free tier of CloudFront, benefit from basically sending your traffic over the AWS backbone, all the way around the world. guaranteed, high reliability, high performance internet routes rather than just sharing alongside all the other internet traffic. That's amazing.
Exactly.
So let's check on that demo. How's the
Cool.
deployment process going?
Yeah, it's ready to go. So let's take a quick side-by-side look of at how these things are, how this distribution is doing. So I just pulled up. I have this screen where we have basically a side-by-side comparison of our CloudFront distribution and our ELB direct to the internet. And you can see that they look a little different. And I did this intentionally. I made the images here red instead of black, just so that we could easily distinguish between the two. And also to show you that we are indeed loading this content off of S3 rather than the ELB origin. But what I can tell you is that both of these applications are using exactly the same EC2 instance. So the performance that we're looking at is strictly modified or improved by CloudFront. So let's take a look at a couple of things here real quick. First of all, we'll just refresh these pages once or twice, and we can see a couple of things start to emerge. Number one, over here on the CloudFront side of things, we can see the cache disposition of each of these assets that are loaded. So we see miss from CloudFront, hit from CloudFront, miss from CloudFront. And what this is basically saying is was this object delivered from cache or was it delivered from the origin? And we see right now that we are loading this from the origin, this from cache, and this from the origin. And if we refresh this page a couple of times, what we're going to start to see emerge is a pattern that says it's going to say miss from CloudFront, hit from CloudFront, hit from CloudFront. And there's good reason for that, right? Effectively, after we get through all 6 images of our dice, we're going to have warmed up that cache, right? So all of those images are now loaded into cache, and we can deliver those from cache every single time. And you can see that, over here, we're loading this content from, directly from the ELB that's located in Australia. And I want to double click on a couple things here that I think are really critically important to take a look at. And let's see. Okay, so I want to get a hit from CloudFront to make sure we can compare apples to apples here. So I'm still warming up that cache a little bit. But once we warm that up, and we should have it warm now. Nope. Sorry, let me try one more time. Here we go. So we have a fully warmed cache now where all of these assets, all the static assets are being delivered from cache, and that's a good thing. And we can take a look at those static asset delivery times first, right? So we can see that this image file was loaded in 63 milliseconds versus 363 milliseconds over here on
Big
the ELB.
difference.
Big difference. And the same thing is true for the CSS file. And the one thing I really wanted to highlight here, I talked about TCP and TLS termination at the edge, and we can actually see the benefits that we get from TCP and TLS termination at the edge. We can see it right here in our Chrome Dev Tools, where we see this initial connection time. And this initial connection time is showing that it took 350 milliseconds to negotiate that TCP and TLS connection. And that's a really big driver in the overall speed that it takes to load this content. And if we look over here on our CloudFront distribution, we see that same connection, or that same establishment of that TCP and TLS connection, took just under 80 milliseconds. So 80 milliseconds versus 350 milliseconds. Again, a huge difference when you're talking about the overall performance of your application. And again, like I said, cost neutral under most circumstances when deploying CloudFront.
That's awesome. I'm really excited to see more people able to benefit from these improvements to their application performance, thanks to CloudFront free tier. Is there anything else you'd like to say before we have to wrap up?
The only thing I'd say is use the free tier. It may sound really simple, but get in there and use it. It was designed for you, and so try it out. And it's a meaningful amount of data transfer, and it's meant to help you get started with CloudFront without incurring any costs. So get in there and use it.
Absolutely. Well, thank you very much for joining us today, Alan. I'm excited to see more folks trying out CloudFront and benefiting from it.
Yeah.
Thanks so much,
Nathan.
Alan.
Appreciate the time.